Hey everybody. So this is going to be lesson 7.5, the last of this chapter, properties of trapezoids and kites. So when you're looking at the vocab, you're going to see there's quite a few new words here, but also our learning targets are going to be properties of trapezoids, finding the trapezoid mid-segment to find distances, and properties of kites, and how do we just identify a quadrilateral. So a trapezoid is absolutely my favorite figure. Don't ask me why. I think it actually has to do with the fact that it's kind of quirky. But a trapezoid is a quadrilateral with exactly one pair of parallel sides. Those parallel sides are called the bases. And in each base, there's a set of angles. So each base has its own set of angles, and these angles are congruent to each other. So you can see they're not opposite angles that are congruent to each other. It's actual base angles that are congruent to each other, similar to what you would see in an isosceles isosceles triangle, where we had the base angles that were equal. Same type of concept. Now, if there's equal legs, like here and here, these are the legs. If they're equal to each other, it's considered an isosceles trapezoid. So a lot of new vocab here, but you could have a trapezoid, isosceles trapezoid, and then we're going to talk a little bit about kite in a little bit. So identifying this in a coordinate plane, a couple ways you could do this. You could see if these are perpendicular to each other, or sorry, not perpendicular, parallel to each other by using slope. So use slope to show parallel bases. That's one way that you can do it. You can use the distance if you want to find out if it's isosceles. You could actually use the distance formula here and here and here and here and decide if it's going to be equal. In this case, it's not, but slope. So you see how this is 2, 1, 2, 1, or rise 1, 2, 1, 2. So either way. Okay. So all the properties of a trapezoid. So in a trapezoid, you have parallel bases. Base angles are congruent. So there's two sets of those, and you have legs that are congruent. You also have diagonals that are congruent, and that is true only in a rectangle or a square. So trapezoid, rectangle, square, those are the three that those are congruent in. Trapezoid mid-segment theorem, this is actually kind of a hoot, because what it does is it splits this up into equal parts, and the mid-segment is parallel to the bases, but it's also half the length of the two added together. So if I took the bases right here and here, and I add them together and divide by 2, that equals the mid-segment. So I take the bases, I add them together, and divide by 2. Another way to write this is 2mn, 2 of the mid-segments are equal to the 2 bases added together. Most people like that better because it eliminates that fraction. But it's exactly the same thing. But I know how you guys are with fractions, so we can eliminate that if we want. So identifying this in a coordinate plane, well, to do that, you first have to graph it. So -5, 6, that's your A, 4, 9, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's going to be up here. 4, 4, 4, 4, C, and -2, 2, B. Just make a quick connection. And you can see it's a trapezoid by just going and finding the slope. So 1, 2, 1, 2, 3, 4, 5, 6. So if I go from here and I go 1, 2, 3, 4, 5, 6, 1, 2, you will notice they have the exact same slope. So this is a trapezoid. Now, is it isosceles? Well, this is 1, 2, 3, 4, 5 units away, I believe, if I remember correctly. So B and C. So 9 minus 4. Yep, 5 units. So if this is exactly 5, this would be isosceles. It is 1, 2, 3, 4, and a little bit more. So I don't know unless I do the distance formula and to show that, but my guess is it's not exactly 5. But let's take a look at something else real quick, see if we can figure it out. 1, 2, 3, 4. 1, 2, 3. Oh, it is exactly 5. So it's isosceles. By the way, I did that in my head using Pythagorean theorem. 3 and 4 and 5 are common right triangles, so it was really easy for me to do, but that's something we'll learn in 2 units from now, I believe, or maybe next unit. And you'll get really used to triangles like that. But you would just use the distance formula in the meantime. Okay, so recall that a mid-segment of a triangle is a segment that connects the midpoints of 2 sides of the triangle. The mid-segment of a trapezoid, right here, is a segment that connects the midpoints of its legs. So midpoint, midpoint, right? These are midpoints for this leg, midpoint for this leg, and it's similar to that. So again, 2 of the middles equals the base plus the base. Okay, let's try an example of some sort. So if EG is equal to FH, is a trapezoid EFGH isosceles? So EG equal to FH, is this a trapezoid? Yes. Congruent diagonals. Okay, the other thing you need to know here is that you have HEF 70 degrees and FGH, this one here, 110, which means that this is 110 and this is 70 because the base angles are congruent and they're consecutive. 70 plus 110 equals 180, and that makes them supplementary angles. So that's another way that you can say this is a trapezoid. Okay, let's try a couple of different examples. So the stone arch of the diagram is an isosceles trapezoid. If I'm looking for the measurement of K, remember that this is congruent. So the measurement of angle K, measurement of angle M, measurement of angle J. So this one is 85. So this is a supplement of this, and so is this. So 180 minus 85 is going to give me 95. And so this is 95 and 95. And now you have your degrees. Okay. So in the diagram, MN is a midsegment of the trapezoid. So a couple things about this. I can add these together and divide by 2. So MN is equal to 12 plus 28 divided by 2, which is equal to 40 divided by 2, or 20. So I know this is 20. When I said there was a couple things about this, this is what I want to show you. The distance between these is going to be exact. So 20 minus 12 is 8, and 28 minus 20 is 8. And I want you to notice that pattern because it can save you a lot of time and trouble someday when you can't remember this exactly, but you might remember that little bit right there. They're equidistant apart. So when you get a problem that's a little more difficult, you have a way now to solve that. Okay? All right. So find the length of the mid segment. So a couple things you can do here. You can identify where the points are. Mid segment YZ, this one right here. You can identify where the points are and use the distance formula. And I'm just going to show you this one instead of writing this out, save us a little bit of time on this video because it's already at 10 minutes. And you get the distance of YZ all the way down here, 6.71. So the midpoint of this and this, you get these 2 points right here. Use those points, plug them into the distance formula, and figure out how long that is. Again, I'm going to repeat that one more time. If I want to find this, this is the midpoint. So I'm going to use the midpoint formula to find Z. So I'm going to add the x's together, add the y's together, and divide each of those by 2. That point is at 7, 2. Then I'm going to go to here, and I'm going to do the same exact thing to find this point right here. Use the midpoint formula because this is midway. So this is midway, and this is midway. So I use that, find the midpoint, get my answer, and then I take these 2 points, use the distance formula to find out how long that segment YZ is. And it's 6.71 units. Okay, so in trapezoid, JKLM, anytime, by the way, that you see something where it says a thing and you just don't have a visual, give yourself a visual. It's really easy to make yourself a quick little visual, and you can start clockwise, counterclockwise. It usually doesn't matter, but start somewhere and then work your way around. So it says J and M are right angles. So I didn't actually make it look like that, did I? But this is a right angle. So JK is 9 centimeters. This is going to actually be one of my legs. So I probably should resketch this real quick because this doesn't look right. And after a while, you're going to be like, what the what? So these are right angles. J, K, L, M. So let's ignore this one. Like I said, after a while, you make yourself a sketch, you're good to go. And this is 9. And this is your mid segment. And they're telling you that this is 12. So sketch it and then find ML. So I'm looking for this length right here. Now I told you that you could take these, divide by 2, do all kinds of funky things. Or you could just look at it and go, well, this is 3 apart, right? 12 minus 9 is 3. So 12 plus 3 is 15. Now, if you actually want to do this, go ahead and do it. JK plus ML, so 9 plus ML divided by 2 is equal to 12. And you could solve that. So 12 times 2 is 24. 24 minus 9 is 15. And you would solve for that. Okay, so a couple ways you can do that. So again, this would be, I'm going to pull it up here so you can see what I just said. 24 is equal to 9 plus ML. All I did was multiply by 2 on both sides to get rid of that 2 in the denominator. Subtract the 9 to get ML equals 15. And again, remember that these are equidistant apart. So if this is 3 away, then this is 3 away. Okay, that's trapezoids. Let's talk kites real quick. A kite is a quadrilateral that has 2 pairs of consecutive congruent sides, but opposite angles are not congruent. So it's kind of deceiving because there is a pair of congruent angles that are opposite each other, but it's only one pair. And it's the pair that makes up this portion and this portion. And the reason for that is isosceles triangles. So if you were to draw an isosceles triangle here, you can see that the base angles are congruent And you can see that the base angles are congruent. So these are the two angles that are congruent to each other. This is not bisected. They just happen to be the entire angle congruent to the entire angle. But these are congruent right here and here, and then right here and here, just to let you know. Okay, so diagonals, 90-degree angle, and I just got done explaining why these are congruent to each other. So in this kite, if you're looking for the measurement of angle D, you are looking for this right here. Remember that I just got done telling you that these are congruent to each other. So let's call it X. So 2X plus 115 plus 73, I believe that's 73, is equal to 360. How do I get that? There's 360 degrees in every quadrilateral. Please don't forget it. So 2X equals 172, and X is equal to 86. So each angle here is 86 degrees. Okay, so in this kite, the angles measure 3x, 75, 90, and 120. Find the value of x and then tell me what measures are congruent to each other, because two of these angles have to be congruent to each other. So 3x plus 75 plus 90 plus 120 are equal to 360. Again, 360 degrees in a quadrilateral. 3x equals 75, so x equals 25. 3 times 25 is 75. So the two angles that are congruent to each other are 75. So that means you have a kite. This and this are 75. And these angles would be the ones that are 90 and 120. Just to give you a quick picture. Okay. So if you are looking at this, you can see that picture that I gave you in a couple lessons ago, how it's more broken down now. You have trapezoids, then you have isosceles trapezoids, parallelograms, rectangles, rhombus, and kites. Give the most specific name for this quadrilateral. This is the last thing about this lesson. This would be a kite. It's really deceiving, but these sides here are equal and these are here are equal. This is a trapezoid. You have one set of opposite angles here. And this is a rhombus. Okay, you are all set. This chapter is done. Be ready to take the test on this soon so that you can get that done. Miss you all. Hopefully we'll see each other soon.